What we're going to do is talk about a brand new software we have called Ruby. And I know some of the education customers that we have already are running Ruby in schools and have already found some really sneaky benefits that have snuck past TroTech, but we have spent hundreds and hundreds and hundreds of hours developing some very nice scenarios on how this brings some benefit to integrate to the broader curriculum. So what we'll cover are some of the benefits and the vision of Ruby. So, why this thing even exists in the first place, why make a change? And then inside Ruby, there's a workflow process that I'll go a little bit deeper into that just, look after some of this management and design and preparation sides of the Ruby software itself. Some other really important parts of this process surround material data. And I know that if we get this right, it's really something that streamlines the productivity of this unit. Material parameters is a big topic in schools. So how do we replicate this or scale this so then multiple people get the same benefit? And then there's some tools and links at the back of this webinar that will direct you in the right spot, depending on if you're current TroTech, new to TroTech, have a RayJet as opposed to a Speedy, or, curious. So a very simple way to explain the process. We go from idea to product. And it's very synonymous with how, teachers teach, that we're going to start with an idea, we're going to create something, we're going to go through problem solving, we're going to, tackle some things that may come up that we don't expect. And at the end of it, hopefully we've got a product or, an assessment or a physical piece of paper that says we achieved something. Ruby acts in a very similar way. So to show kind of the speed of the processing, there's a video here that will go from the importing of a design to the final stage of the product. So we're in a design tab at the moment. We can open our file, drop it straight into Ruby. At this point, it still can be edited. Once we've got our job in our design page, we can send it to the prepare page, duplicate it, send it to a queue, and it's ready to process. So we're talking 3, 4, 5 clicks for something that we're skilled at or understand. Once you're fluent with lasers and you've had them 2, 3, 4 years, this process to go from one to the next is incredibly quick. In some circumstances, you can get it into this queue without even needing a computer. So we can start introducing iPads or, Chromebooks or things like this that can start to enable a bit of a broader reach on design software. The next one here is using Illustrator. I've been a little bit sneaky and threw up a few questions on some Facebook groups to ask what design software schools are using. 67% of the 187 people that responded using Illustrator. So we know this is a big pain in the school industry, that you're constantly battling line weights and colors and, thicknesses and shapes and all these types of things. Very complex from the early days. So this is going to take that whole learning curve to a whole nother level. So you'll see in this video, the exporting of a file out of Illustrator and then bringing this native Illustrator file into Ruby to be able to edit it. So it's a stock standard save as Illustrator file. And we'll just drag the Illustrator file straight into the management tab. So on this page, you have a list of designs and a list of jobs. You might see that at the top left. So the Illustrator files natively imported straight into Ruby. Now, one thing, I'll just pause it right there. So on the right-hand side there, you can see the black paths and the one text that says Express Coffee House. That text has come in as editable straight out of Illustrator. So we can still continue to manipulate information once it's inside Ruby. So you don't need to be as fussy in Illustrator. And then you can see number 6, the green parameter as a path has been recognized in Ruby automatically. It's been set correctly, but the 2 brown tones underneath have a little warning sign. So the warning sign is telling us that that layer has not been recognized by Ruby. Now we've got an opportunity to change it and fix it. So the same would work with a CMYK red cut line. Ruby would have that imported and it would realize that it's CMYK red and not RGB red, and automatically we can change this. And also another thing to note here is that line weight is significantly thicker than a hairline or 0.001. Doesn't matter in Ruby's language. If we assign red to a cut, it's going to cut. Days of line thicknesses, that's just drama central, going forward and back constantly until you get your file right. But the whole time you're doing that, you're holding up the job queue from the next operator from getting his work done. So Ruby being networked or able to be collaborated with broadly means that everyone can continue to work in this software platform while it's working, which is really, really nice. So here we'll cover a bit of the drop-down menu, or what might look like a little bit behind the scenes with Ruby and how it's set up and how it thinks. So the top 4 you see here are the main 4 functions inside Ruby, or that idea from going idea to product. So manage, design, prepare, produce. That's the common way to use the machine in this format. You've got a materials database that's accessible here. It's also able to be backed up through the cloud or downloaded new settings from the cloud as well. You've got a user management section that I'll touch on, which also starts to talk about network activity and locally hosted platforms, and using this software at home instead of on the premises at school. There's some settings and calibration information we might skip over for now, and then obviously the help tools. The feedback tool is very nice, because if you submit feedback through Ruby, it goes directly to Christoph and Stefan and Alex, the people that build it, and gives them direct feedback about what you think might improve it. So not many platforms give you that access, which is very powerful. And if you think that, like I've had one school has asked for Boolean searching, of course, that's something we bring up with the development team, and they tell us it's on the list of things to do. The more people that ask for these things, the quicker it is to get the benefit. We've got a knowledge base, which will take you through more specific information or how-tos or tutorials inside Ruby, so you know what to click next. There's some service file information that can help us diagnose issues if there is an issue, and manuals will take us straight to a laser manual. So this goes a little bit deeper into one of these sections. So like I explained, manage, design, prepare, produce. Like you can see at the top, the 4 icons represent these 4 tabs. So you can cycle forward and back through these icons as you need to set your work up. Each icon will have a different level of functionality within it on the screen. What you see here is the produce screen is a laser queue. You could essentially have this queue set up in every classroom across the school that might be submitting files into it. You can see who's doing work and when. This is our materials data. So you can see it's pretty comprehensive with default settings already. And we can go through and start to add more information in there. This is the user management. So you can see it all accessed through remote link. We can go a bit deeper into this in a second. This is all the configuration settings that we can start to include. So, we are global, so we have different languages, but also, the integration between its own systems. So if we're telling an exhaust to turn on 5 seconds before and hold 15 seconds after, all these things are able to be collaborated with and are able to feed analytics back to the laser unit and the operator to make good, safe decisions. What we'll see here, we'll go across down to, help and the feedback and the knowledge base. This is a small tour. It will just take you through different sections and explain what they are. So early days is very good to use, just to, give you that little nudge, get you to the next step. Feedback, like I explained, I don't know what other platforms give you that kind of access directly to a development team, but this is very powerful. When I talk to these people consistently and they ask me more feedback, and they tell us, get your customers to submit this information through the feedback form, and this helps build Ruby in its future generation. So the service file, this will just show you how to do that. It'll automatically download this for you. And you can simply email that to us and we can assess it and work out what might be wrong with that point in time. I know we had some issues down at Salisbury High School early days, and they were one of the first schools to put Ruby on their system with a 360 Flex. And this was able to help us pinpoint an issue pretty quickly and work out what the cause was and solve that. So it was quite nice to have that access, especially going directly through the Austrians, they're on call. User management. So there's 3 levels of user that can have access inside Ruby. You have a super admin, which would be someone that's the system. So we might have head of department or your IT services or a permanent contact at the school that may be the person that is a super admin. And this is a person that will authorize the initialization of Ruby. So it's the first person that contacts the Ruby side. Underneath this, you have your admin team. So this could be someone that is designed from the super admin, so your teaching staff primarily. And these admin team will basically be able to have all the administrator access that a super admin can. So they can lock users, they can give material data access to certain people. So it's really good to use in the teacher's sense. And you can also then have a user, which is essentially can be restricted in access. So if you didn't want your user as a student to have material data access or to see the admin team, you can restrict this level as well. So no one's going to mess with anyone else's work. You're not going to lose your files, and you're not going to get your settings or materials manipulated with. As far as the networking is concerned, you'll have a host PC, which has a Ruby install on this host PC. Primarily, it's the computer that's attached to your laser. That machine will then be connected through your network. And from that network can then send a remote link into iPads, Macs, PCs. You know, the list is almost endless here, as long as it can run a browser. So we can set up iPads to have this connectivity straight into Ruby. So we can walk onto the school oval, take a photo and send this photo into the Ruby queue in, you know, Makerspace Lab 12. There is just so much control and so many scenarios that this gives more access to, that the remote usability of Ruby means 3 classes can run simultaneously, and you can walk into the makerspace with the machine or wherever your machine is when it's your time. So this whole bottleneck idea doesn't necessarily exist. You know, schools that may put 3, 4, 5 machines in, do you really need 3, 4, 5 machines? So we're going to start to introduce ways in which we can have machines that are more associated with a process. So a high-powered machine or a low-powered machine. And one machine will be better at the job than a different machine. So we can get smarter about our capabilities that we have on site and get a better output. There's one more way to access Ruby. So if you were wanting to work with Ruby at home, this comes up every single time I do a Ruby installation. So we have to load the software onto that individual PC to be able to run it offline. But by the time we're back on the same network, as long as we can connect into the network, we can then submit these files into the lasers queue to be able to process. So this is how it works today, in a very basic sense. You know, I'm not an IT engineer. I don't completely understand the back end of networking, but I know loosely how it works and how it doesn't. So now we jump into the management page. There'll be a video in here that will explain a little bit deeper about the management process. So a list of designs and a list of jobs. Designs could be things that have been imported from Illustrator, PDFs, SVGs. Jobs that maybe have been made up of multiple designs to run one job. So if you wanted to repeat work, you can repeat a job very easily. So what we're showing here is, you know, deleting files, exporting files. You can see here there's a zip folder that's been created. What's really nice, the other day we've worked out that we can actually import a folder straight off our desktop, even if it's got a mix of SVG, PDF and Illustrator all in the one folder. So if a student doesn't quite read the brief and exports as a PDF instead of an Illustrator file, doesn't matter. We can import all together in one hit. We can still edit. What you saw there was a job being dragged from the jobs queue straight into the laser unit. So 2 clicks and you're cutting. This is our design tab where we can basically set up a brand new design or create an object. We can import directly this way as well. So, you know, drag and drop like everyone is used to. There's other ways to import files. Very nice tagging structure, which we're going through here. So the tagging system is very useful if we're going to start to isolate jobs by class member or by teacher or by, you know, material type. Understand this is a lot of information and I'm probably going pretty quick, so please note questions as a little reminder. Here we're going to look a little bit deeper into the design page. So there's some basic design elements inside Ruby which are quite nice. So we can draw ellipses and squares and lines, and we can trim down objects. What we've done here is drawn an ellipse and we've turned the ellipse into a clipping mask. We can select both, you know, the tiger and the clipping mask and remove the outside the clipping mask and keep what's inside the clipping mask. So I know a lot of schools, you know, try to introduce photo engraving early days, and the photo engraving algorithms that are built into Ruby are exceptionally better to what we used to. And in the future, we're going to start to introduce the ability to change the tone of the graphic. So if you want more whites in this graphic or more dark in this graphic, then we've got the ability to do this inside Ruby directly. Go to the next design video. So we're showing an Illustrator file that's been put into Ruby. And here we're starting again to manipulate some of the paths and the objects that are relevant inside the layer list. So you can see line thickness. So I know this is a big topic from the Illustrator world, but in our terminology, both of those red lines will cut regardless of how thick they are, because against the red color or the red layer, we are telling the laser to cut. In this example, he's converted this thickness of a line to a border that's going to be engraved. Got the ability to mirror and flip and also rotate. So there's infinite rotate capability in here. So it's really nice that I guess those of us that are used to lasers would get it through a printer driver program and only be able to rotate 90 degrees, only in one format, like literally 90, not 270. So now we can rotate infinitely as well, which is quite nice. Really good for nesting against products that may be really odds and ends of cut acrylic that would normally go to waste. We'll drag the job to the crosshair of the laser. So that little marker at the top left of that job is the red dot. Select your material, push the laser, and it appears in your queue. So that would sit there until we insert the material, we focus the machine, we push play either on the machine or on the PC directly connected. So especially when we have this networking discussion and we've got 3 to 10 to 20 people that are accessing files to this machine, only the machine that is directly connected, the PC that is directly connected to the laser can push play for safety. And there's a nice little line engraved on a piece of mirrored acrylic. Go to the next video, jump into the prepare screen. So this is pretty unique, and I guess I only know one school that I've shown this machine so far. So you'd see first straight away on the right-hand side, there's actually a touchpad that's built onto the machine. So this unit has an inbuilt Linux box that is running Ruby. So we call it a Speedy 400 with Ruby inside. And it's made to hold jobs in a queue. So you saw the operator there move the laser head and focus using sonar. You can see now we're setting up another job. We're on the prepare tab. On the left-hand side, you've got access to your designs and your jobs. So you could import multiple designs or multiple students' work onto one bed. And you'll see in this example, we're collaborating a few different designs to build one product. So there's some cutting, red lines for the cut. We're introducing another graphic, join these together. So we're overlaying 2 jobs. This was never possible. Now we're going to draw an extra shape at the final stage of the laser process. Keep in mind you're 2 touches away from cutting this thing at this point. What's really nice is the ability to be able to adjust at the very last stage of the process. So I know with teachers who are used to scaling so they can get boxes to fit together, push fit with no glue. It's really nice. Here we've just snapped 2 jobs next to each other left and right. And inbuilt inside Ruby is a skip overlapping cut line function. So that middle line, which is currently shared, because you saw the operator draw a rectangle, we're now going to tell that laser to cut that once, not twice. Laser will make a very smart decision to cut the path in a very strategic way. So then it will essentially not have to overlap or travel a further distance to be able to do the outside cut. So it started at the bottom in the center, completely gone around to make a rectangle, and then come vertically straight back up to the top. So there's 0 wastage between these 2 pieces. The cut time's quicker, so you're more productive, you earn more money, put it that way. And you know, the quality of output's much better. In the old way, you'd have to physically remove that line from Illustrator and import it into your printer driver to be able to cut it correctly. Here is kind of a real example. So you'll see on the left-hand side, there's a piece of fluted cardboard, and you can see the 2 circles that I've drawn in there in red highlight. It looks a bit darker than the other rectangles in that little piece of the, you know, I don't know what country that is, but wherever that is from, off Madagascar or something. So, and I've zoomed in on that section because you can see that the line is darker. So this is the trademark, you know, devil of overlapping cut lines. If we were to do this on the wooden clock on the right-hand side and we didn't know that there were 6 or 50 lines overlapping, then, you know, we've just lost Madagascar and it's gone all the way through and it's just ruined our clock. So if we were to be able to stop these issues from happening, or we can catch them by cutting cardboard as a prototype first, and we can instantly see that that graphic's wrong, we know the students got a part of the process incorrect, and we can manipulate that and rectify it before we actually cut our nice expensive piece of Trotec wood. So the common line sharing thing also will reduce the risk of fire. If we're going to introduce cutting on cardboard or papers or things like this to prototype, and there are 50 cut lines over the top of it, then we can reduce this problem from becoming a serious problem, because we are at the end of the day using heat to cut. So quite nice function that's built in, and it can also skip straight lines or straight lines and curves, which is very nice. So you can tell it to do that at the top right there, and it always automatically will cut the inner geometry before the external geometry. Now we're back on the prepare screen. So we've taken a job and we've put the job on the plate. And you see now we're going to look at the material data. So we would select the material setting from the list. The black is associated against the engraving, and you can see there it's called engraving dark. I'll explain this in a minute. But we can make minor adjustments or major adjustments to this parameter, and it doesn't affect the master parameter list. So this setting that we've just changed from 60% speed to 40% speed is relevant for this one job. So this one job, if we repeat it in 12 months' time, would remember that information that's relative to that specific job. So if we want to disengage a cut line, we just untick it. Or if we want to disengage the engraving, we untick it. So you might find sometimes cutting the product first and then peeling and masking off, and then sending a second job that turns off the cut but on the engrave is quite useful. Once you've made your manipulations, you've got the opportunity to either store this material change that you've made and overwrite the existing, like you see here, or you can make a temporary change, which will only be relevant to this one job, or you can reset it back to the factory database. Or you can make a completely new setting. So there's a lot of flexibility in the material data, which again is shared amongst users. So if we had 20 users, that's pre-printed material. So it's another feature. Like you can see at the top there, there's extra features that I've not explained yet. So it can go quite deep, and I'm happy to have a deeper conversation. We're going to look at material data in a little bit more depth. So on the left-hand side, you've got the default material list. We can isolate and separate through searching what we want to hunt down. Also, you can see at the top there, underneath wood, plywood, 3mm, there is the tagging system is still relevant here. And this list is called an effects list. So if we wanted to start to use terminology to provide a process, then we can rename an effects list. We can call it 3mm deep engraving, and we can program these things in. So the next time we go to do 3mm deep engraving for next year's classes, it's already preset. We don't need to make all these deep assessments into materials assessments to be able to work out what we need to do our job. One thing I'm going to pause on here is the fact that one setting, so this parameter for wood plywood at 3mm has got 3 different engraving settings using 2 different resolutions. So because there is 0 printer driver activity in this whole process start to finish, we can isolate parts of the job to run at certain resolutions. This is incredible control that, if it's used correctly, saves you a bucket load of time rather than just running things at 1000 DPI because we think it's the best. We can then now specifically change the DPI to suit the job. So you can run, 3, 4, 5 different DPIs in one job quite easily. Perfect for if you want to engrave photos and you want to work what resolution gives you the best result as opposed to time. You save your material data and it will log that automatically for everyone. Then if you wanted to import new settings, add a brand new one, or we could export them so we could use them later or keep them safe, we can do that. Really, really simple. But it's nice how in our old world, you had 16 color parameters with 16 powers and speeds. Some of them said 0, and it was really daunting and overwhelming for a student to know what color to touch. Whereas in this example, you had black and red. Black for engrave, red for cut, and that's how a majority of this industry talk. So you can see we've just built a setting, we've assigned our engraving to this brand new setting we made, add it to the queue, move on. Go to the next slide here. Future benefits of Ruby. Hang in there because we're nearly there. So this is a bit of a snapshot of what we're working on. So currently, we're working with PDF, AI, JPEG, SVG, and PNG files. Perfectly accessible to start to use Tinkercad, start to use MakerCase, using Fusion, using Autodesk, other, Inventor programs. Rhinoceros has PDF export. So this type of file export touches really education more than industry. So there's no Corel Draw import here. So, I had a customer today from a trophy shop that first thing he asked, can I use my 5,500 Corel Draw files right now? No. There's a way that we can do it, which we have to export these files as SVG and, save them and update them. But the fact we can import an Illustrator file and automatically edit this on the fly, incredibly powerful. Simplifying of engraving of cylindrical products. So there is a virtual rotary system that's inside Ruby. I'll share this with you because it's quite interesting. You don't need a rotary kit to show what a rotary kit does, which is quite nice. So you can explain it through the, the maths angle. Create complex geometries and clipping masks. So we can use all the union and intersection and difference tools inside the design tab to make new geometries and shapes. Use your laser without a PC. Obviously very possible. Print and cut jobs, any operating system, so it's Mac friendly. We still need a Windows PC to act as a host. So, but the fact that I can whip out my iPhone and take a photo of, Roger out the front and put him inside Ruby and put him on a beer glass is pretty impressive. Use multiple machines from one PC. So these are things that will come. So the schools that have 2 or 3 speedies, we can start assigning work to the machine that's got the least amount of work in its queue. So if we wanted to go up to level 5 to use it, rather than, walk downstairs, we could start to allocate our work against the machine, the right machine for the job. Prepare laser jobs from anywhere. This is very real at the moment, and no job time up front, the things that we've put in. So 2022, we've got a list of things that are considered priorities, a list of things that are not as much of a priority. And that's where this feedback information really starts to influence what we will do next year. So, auto nesting, variable data, we've got a lot of very clever ways that we can start to look at API integration. So, if students are building websites, there's no reason why they can't tell a laser to do something. Lasers will have RFID readers in them in the future, input, output. So we can get very clever, very quick. So I guess some of the existing Trotec schools that might have a machine. So this is really relating to the schools that have anything from the speedy range. So all the way from a 100 up to a 400, plus the SP 500, which I've only got 2 in education here in Adelaide that are a university. They won't be in on this data conversation. You need to create a Ruby account. So you could do that yourself through our website. That QR code will take you straight there to do this. Alternatively, reach out to me and I can set you up and we can have this discussion about how it would work best in your scenario. I'm happy to discuss this with your IT teams. Every school has its own challenges, which is perfectly normal, but we'll work through that type of stuff together to get it running and not affect the current workload. Ruby works hand in hand with job control currently. So you'll never lose job control. It's still active. You'll just choose which one you may want to work with. And the other half of the room that might have RayJet machines, Ruby is not possible to act with a RayJet. So I'm happy to look at some scenarios that we could put together to get you your hands on a speedy system. So we need to move and adapt to this technology. And that's where, industry is speaking Ruby. Students need the intelligence of Ruby. As I'm getting firsthand, students straight out of schools that are bringing mum and dad into here to work out the future of their laser processing. It's very real. I have these conversations from a student at Pader. Came in, a few weeks back, got mum and dad involved, and all of a sudden they buy a Speedy 360. So these things move quicker than we can imagine. We've got a website here for those customers that already are on Ruby. Some may know about this, some may not, but this is rubyhelp.com. On this website, we've got some guides that will talk you through, like I've just done just then, but in a lot more depth, about what these buttons do, what their functions are. So this is a really nice kind of workflow assessment. So if you wanted to use some of this for your own curriculum, you know, you could pinch some of these bits and pieces out of this. It's really cool. Even for troubleshooting, you know, there's some things in here. You might have some login issues which might relate to your network. So this will just give you a few tips and tricks to point you in the right direction, but really quite comprehensive, which is quite nice. And all the updates for the future versions of Ruby will have information that comes out of here. Also, we have a consumables education pack. Some of you may know about it. If we scan that QR code, that'll take you to this information page. It's engravingssuppliers.com.au is our consumables website. But you'll see inside this consumables pack, there's $360 worth of materials for $200. And it comes with DIYs relevant for the curriculum, comes with settings, comes with a lot of concepts that you can use this information for. So it's really good early days for customers that might start their laser journey. They might want to, you know, get a range of materials from acrylics to wood to paper to cork to rubber to whatever. And this is a really good start. So a way to get off the ground is really nice and quite cheap. For more info, if you scan that QR code, it'll open on your phone as a little form that you can chuck your email address in. That'll come to me. You know, I'm accessible as they come. I'm happy for the education market to talk on my behalf. There are now 85 lasers in schools in South Australia, some with 4, some with 5. And this is very impressive that there's so much knowledge going on about how lasers are used in the industry, and that's getting twisted into schools. So I'm a source of knowledge. This is why this room is built. That we built this in the middle of COVID last year, spent a bucket load of money to hold PD for teachers. I've got industry relative things here that actually are getting made by, you know, robotic lines and things that are, you know, laser engraving soil and doing things that are seriously next level. And to come in and upskill, I'm happy to give certificates, you know, sit down and give extra training or come on site and discuss any new opportunities. You know, line's always open. That is it from my side. I'm sure that was information overload, but this is a big discussion. As you can probably tell, I'm quite passionate about it, and I've been quite active in many, many schools that have this system already. So I'm not stopping. I still got energy, still going to happen. So very cool.